Good day, students. You are welcome to sirMATHS in our mathematical journey in the world of numbers. Today we are going to treat HCF. Or was some country called HCF, as it concerns grade 7, equivalent to JSS1. Thereafter, we discuss our LCM. For our HCF, what HCF means is highest common multiple, highest common factor. And that is the highest number, the biggest number, the greater number that can divide given numbers without a remainder. A number that can divide given numbers without a remainder. For example, we have 6, 8, 10. The highest number that can divide 6 and divide 8 and divide 10 without a remainder is 2. So in this instance, 2 is the highest common factor of 6, 8, and 10. The highest number, I repeat, that can divide the given numbers. This is the highest number that can divide these given numbers, 6, 8, and 10, without a remainder. Now, let us look at some examples, further examples, to buttress this our discussion. Where we have a number, example, we have 6 and 18. 6 and 18. We are asked to find the HCF of 6 and 18. We simply say 6, 18. 2 can divide 6 and divide 18. If 6 is divided by 2 is 6 is divided by 2, it will give us 3. 18 divided by 2 will give us 9. Something else can do that for us. 3 can divide 3 to give us 1, and 3 can divide 9 to give us 3. Therefore, our HCF or GCF will be 2 times 3, and that will give us 6. I repeat, that will give us 6. So the highest number, the biggest factor that can divide 6 and 18 is 6. Because 6 can divide 6 without a remainder, and 6 can divide 18 without a remainder. That is our HCF for that number. Let's have a number like 26. We expected to find the HCF of 26 and 169. We have our 26, 169. We ask ourselves, what is that number that can divide 26 without a remainder and divide 169 without a remainder? 2 can divide this, but 2 cannot divide this. 3 cannot divide this, and 3 cannot divide this. If you watch very well, you discover that 13 will do that for us. So 13 dividing 26 will give us 2. And 13 dividing 169 will give us 13. No other number that can divide 2 and divide 13 without a remainder. We stop so far and collect by saying that our HCF is equal to 13. The greater common factor for 26 and 169 is 13. That is our answer for that one. Let's have example 3. Something like 7 and 8. And we're asked to find the HCF of 7 and 8. We have our 7, we have our 8. 2 can divide 8 without a remainder, but 2 cannot divide 7. 4 can divide 8 without a remainder, 4 cannot divide 7. And 7 can divide 7, but cannot divide 8. So in this instance, our HCF is 1. And the result remains 7 and 8. Here we have 7 and 8. No other factor that can divide 7 and divide 8 without a remainder. Our HCF here is 1. Remember I said HCF is the same thing as GCF, greatest common factor. Greatest common factor or highest common factor. This is our HCF for these very 3 examples. We may have something more than that. Let's have another example. Six, 24 and 72. We're expected to find the greatest common factor of these 1, 2, 3 numbers. 6, 24, 72. 2 can divide each of them to give us 3, and here to give us 12, and here we give us 36. Something can still go. 3 can do that. 3 dividing 3 is 1. 3 dividing 12 is 4. And 3 dividing 36 will give us 12. No other number that can, no factor can divide 1, 4, and 12 without a remainder. So our highest common factor for this, or greatest common factor, is equal to 2 times 3, and that is 6. So 6 is the greatest common factor of 6, 24, and 72. Now, let's have this very one again that will involve, this one is the word problem. Let's have one problem in this very highest common factor, the word problem. Let's look at this very question here. What we have here says that Meg caused 12 pink roses and 18 white roses from the bush in her backyard. If she wants to make identical flower arrangements with no flower left over, what is the greatest number of the arrangement can Meg make out of these roses? Pink roses and white roses. This question demands finding the highest common factor. You simply tell the whomsoever that 12 and 18, 2 will go, 2 here will give us 6, and 2 here will give us 9. Something else can do that, and that is 3 to give us 2. 3 dividing 9 will give us 3. Nothing can divide 2 and 3 without a remainder. So our highest common factor or greatest common factor is 2 times 3, which is 6. So Meg will make 6 of that very arrangement. In other words, in each of those very 6, in each of them, there will be 2 pink roses and 3 white roses in each of them. So that is the highest common factor That is the greatest number of arrangements that can make out of these 12 pink roses and 18 white roses. It's talking about the highest common factor. That is it for our HCF. Let us now go to another aspect of this, which is the lowest common factor. The lowest common factor, or the least common factor, whichever way it is called, it is LCM, the least common factor. Lowest common multiple, not factor this time around, LCM. It can be called the least, the same common factor, common multiple. And that is still LCM. This time around, we are talking of the lowest number, the lowest one number that each of the given numbers can divide without a remainder. You said the lowest number that is the result of the multiple of each of those given numbers. I take it again. The lowest value that the given numbers, each of them can divide that number without a remainder. We call it the least common factor. Let's have this. We are expected to find the least common factor of 24 and 72. Here we have 24 and 72. 2 can go on. We start with the lowest multiple, the lowest factor, the least of them. It's better that way. This will give us 12 and this will give us 36. 2 can still go. This will be 6 and this will be 18. 2 can still go, giving us 3 and this one 9. That is 18 divided by 2, 9. 3 can divide, this will be 1 and this will be 3. 3 can divide, this is already 1 and this will now be 1. You keep on dividing until the last values will be 1. And then you now say that the least common multiple, the lowest number that each of these numbers will divide without a remainder, will be 2 times 2 times 2 times 3 times 3. And 2 times 2 will give us 4. 4 times 2 will give us 8. And 3 times 3 will give us 9. 8 times 9 will give us 72. That means that this is the lowest number. The lowest number that 24 can divide without a remainder. And 72 can divide it without a remainder. So this is our least common multiple, or lowest common multiple. Let's have a second example. 7 and 24. Or rather, let's make it 28. We have our 7, 28. 2 can divide 28 without a remainder. So inside without 2, this remains 7 because it's not divisible by 2 without a remainder. And 28 divided by 2 will give us 14. 2 can still go. This remains 7. This is now 7. 14 divided by 2. And 7 will go, giving us 1, 1. So our least common multiple will give us 2 times 2 times 7, and that will result to 28. That is for that. 28, the lowest number, the lowest value. And 7 can divide without a remainder, and 28 can divide without a remainder. That is 4. Let's have another 1 or 2 examples before we end this. Let's be asked to find the LCM of 2, 6, and 8. 2, 6, and 8. 2, 6, 8. 2 can go. This will be 1. This will be 3. This will be 4. 2 can still go again. This remain 1. This is 3, and this will now be 2. 2 can still go. 1, 3, 1, and then 3, 1, 1, 1. So our LCM will give us 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So 24 is our least common multiple for 2, 6, and 8. That is for that. Let us look at one word problem. One word problem in this very matter. Here we are told that Ken made 2 types of pies, strawberry and blueberry. He cut all the strawberry pieces into 12 slices each, and all the blueberry into 9 slices each. If Kenny cut the same total number of slices each type of pie, what is the minimum number of slices of each type he will have cut? We have 12, we have 9. What this is demanding from us is to find the lowest common multiple. In other words, the lowest number that 12 can divide without a remainder and 9 can divide without a remainder. We now answer by saying 12, 9. 2 can divide 12, giving us 6. This remains 9. 2 can still divide 6 to give us 3. This remains 9. 3 will now go. This will give us 1, 3. And 3 will still go again, giving us 1, 1. So Kenny will have a minimum number of slices of each type he will cut to be, we call LCM, equals to 2 times 2 times 3 times 3. And 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is 36. That will be the lowest or the minimum or the least number of slices of each type Kenny will cut. This is our LCM, the word problem of this LCM. I do hope we are all following. Now let's go on to another good aspect still on this. We're expected to find the LCM of 8 and 64. In other words, find the LCM of 8 and 64 and write your answer in index form. index form. Index form is the same thing as exponential notation. Some countries call it exponential notation. Let me see write it. Now we have our 8 and 64. You'll agree with me that 2 can divide each of these. We start from 2. Dividing 8 by 2 will give us 4. Dividing 64 by 2 will give us 32. 2 will still go. This will now be 2 and this will be 16. 2 will still go. This will be 1 and this will be 8. We can still go on with 2. This already 1. This will be 4. 2 again, already 1. This will be 2. And 2 again, this is 1 and this is 1. So our LCM is equals to 2 times 2 times 2 times 2 times 2. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Remain 1 times 2. Then in index form, this is equals to 2 raised to power 6. We have answered the question. Finding the LCM of 8 and 64 and writing our answer in exponential notation or index form. That is for this. I hope we all are following. One more example on this. The combination of the two, HCF and LCM combined. What is the product? Question say, what is the product of the HCF and LCM of these numbers 6 and 9. We expected to find the product of the HCF and the LCM of 6 and 9. This is 6, this is 9. Let's find the HCF. 2 cannot go, 2 can divide this, but 2 cannot divide 9. But 3 can do that. We have 3. Dividing this by 3, we have 2, and this will be 3. We now have got our HCF. Our HCF here is equal to 3. Because no other number that can divide 2 and divide 3 without a remainder. To get our LCM, we continue. 2 can go, this will be 1, this will be 3. 3 can go, this will be 1, this will be 1. So our LCM is 3 times 2 times 3. And that will give us 3 times 2 is 6, and 6 times 3 is 18. So the product of the HCF times LCM, that will be 3 times 18. 3 times 8 will give us 24. We write 4 and carry 2. 3 times 1 is 3, 3 plus 2 is 5. So the product of the LCM and HCF of 6 and 9 has given us 54. That is for our HCF or GCF and our LCM. and this is our lesson today. Please don't forget to subscribe to sirMATHS and turn on notification to stay updated on this our daily maths adventure by clicking on the subscribe and bell notation. Just press the button and we follow. Please don't fail. Thank you for listening. Next week, by God's grace, we'll meet again. But I remind you, don't fail to subscribe.